Imagine waking up to find that the primary tool you rely on to write code, pass data, or manage your business is entirely gone. When a premier AI model gets hit with a region lock or a sudden ban, your access disappears overnight. The AI industry spent its first decade building an architecture where users simply rent intelligence from centralized remote servers. For a developer running continuous autonomous agents, the meter never stops. Processing context across thousands of steps, compounding over an 8-month project, easily consumes tens of billions of tokens, turning daily tasks into thousands of dollars in API invoices. Then there is the liability of the data itself. Every time an assistant debugs proprietary software or summarizes sensitive health records, that information leaves your local machine and sits in the third-party server log. Even when budgets allow and compliance officers approve, you are still waiting in server queues. Processing queries hundreds of miles away introduces hundreds of milliseconds of latency, which makes real-time applications consistently sluggish. Operating this way makes you a digital tenant. Because the model lives on hardware you do not own, your capability to use it can be revoked instantly. 3 years ago, running a capable AI model locally meant owning either a research-grade GPU cluster or a specialized workstation. Today, those same operations run on standard consumer laptops. This shift happened because hardware limitations forced engineers to rethink how data is stored, leading to an efficiency technique called quantization. Quantization reduces the mathematical precision of these learned weights from 32-bit to 4-bit. Shrinking these values reduces the memory footprint by up to 8 times. Despite the smaller size, the model retains roughly 95% of its original accuracy. By optimizing the underlying math, massive neural networks that previously required a data center can now physically fit inside a backpack. Fitting the model into memory is only the first step. Making it run without exhausting the machine's resources requires an architectural approach known as mixture of experts. Traditional models inefficiently activate all parameters for every task, like making every specialist in a building work on every problem simultaneously. Mixture of experts acts as a dispatcher, routing each task to a relevant subset of parameters, leaving the rest idle. Because the machine is no longer struggling to light up the entire network at once, local models can now generate text at speeds once limited to remote clusters, making real-time interaction a reality. Hardware utilization is further maximized by a shift in how models produce text, known as text diffusion. Traditional cloud AI models typically operate exactly like a mechanical typewriter, predicting and producing one token at a time. This works for large data centers where thousands of requests are batched together, but it leaves the majority of a single local GPU's capacity dormant. On this diagram, you can see the sequential method on the left compared to text diffusion on the right. Instead of token-by-token generation, the diffusion model keeps the GPU fully engaged by stamping out entire blocks of text simultaneously. By abandoning data center logic and optimizing for individual silicon, open-weight models can now achieve performance that approaches the frontier for free. This creates a new paradigm: highly capable AI running entirely offline on your own machine at zero marginal cost. This does not mean the cloud is obsolete. There is still a reasoning gap on the most complex architectural puzzles. What changes is the way you use it. The solution is a hybrid workflow. This routing matrix categorizes your work before compute is spent. 80% of standard tasks route directly to the local model. The remaining 20%, complex puzzles requiring frontier intelligence, are passed to the cloud, keeping paid calls infrequent. Adopting this new localized routing architecture isolates your proprietary data, and it removes the bulk of your API overhead. It ensures your digital intelligence runs wherever your work actually happens.